Abby.
Andy!
You gotta help me.
Man, you seem to need a lot of help these days.
Look, an evil bad guy stole my wallet.
An evil bad guy, huh?
Yeah, and I have it on good authority that right now he's 8 blocks north of here and 5 blocks east.
Then what are we waiting for? Let's go get him.
Not so fast. We gotta come up with a plan of attack.
Oh, okay. I'm down.
First things first, we must figure out how many different ways we can get there by traveling either north or east.
Well, there's only one way to get 1 block north of here. And there's one way to get 1 block east of here, right? So that means that there are 2 ways to go 1 block north and 1 block east of here.
Oh yeah, you could either head north then east or east then north.
Exactly. The way to figure out the number of paths to a specific street corner is to add up the total number of possible paths from the 2 street corners that lead up to the new street corner. Think of each street corner as a node on a graph. In order to reach a new node, you must travel through one of 2 previous nodes, and that's why the total number of paths to that new node is the sum of the paths to each of the preceding 2 nodes.
Aha! So for instance, because there are 15 ways to go 4 blocks north and 2 blocks east of here, and there are 20 ways to go 3 blocks north and 3 blocks east of here, then that means there are 15 plus 20 equals 35 ways to go 4 blocks north and 3 blocks east of here.
Exactly. And if you continue this process, you will build up what is known as Pascal's triangle, which was named for French mathematician Blaise Pascal. And thus, you will find that there are 1,287 different ways to get from here to there.
Wow, that's a lot, especially considering that we're just traveling 13 blocks.
And while building that diagram, you may have noticed that it mirrors itself. For instance, there are the same amount of paths going north A blocks and east B blocks as there are going north B blocks and east A blocks.
I thought the numbers were looking similar. So what if we were 100 blocks north and 72 blocks east? That would take an awful long time to draw the full diagram.
I'm so glad you asked. There is in fact a shortcut. In each node, you're walking a total of C blocks, and then choosing to go north A times while choosing to go east B times, where A plus B equals C. So the equation to get the number of possible paths is C choose A, which equals C choose B, which equals C factorial divided by the product of A factorial and B factorial.
Wait, what's a factorial?
Go back to episode 1, you crazy cat, you.
Yeah, I knew that. I was just testing to see if you had watched any previous episodes.
Right. Anyway, that means that if you wanted to go 100 blocks north and 72 blocks east, then there would be 172 choose 100 different possible paths.
Which ends up being the same number as 172 choose 72.
Yes! Are you ready to catch this crook?
Well, he'll be looking for us to be coming from the south or the west of where he is now. So I say we should avoid those 2 blocks and instead head either a block north or east of him and then cut back. How many different ways can we do that?
Oh boy! If you want to avoid traveling through the street corner that's 8 blocks north and 4 blocks east of here, as well as the one that's 7 blocks north and 5 blocks east of here, then instead we'll need to travel to the one that's 9 blocks north and 3 blocks east of here, or else the one that's 6 blocks north and 6 blocks east of here. Once we reach either of those 2 spots, we cut over and back. And since we won't walk any additional blocks out of the way from that point, the final answer is the sum of possible paths to those 2 destinations. So that's 12 choose 9 plus 12 choose 6, which is 220 plus 924, which equals 1,144.
It's interesting that there are less paths for the roundabout way than the straight-on way.
It is interesting.
I wonder if that's always the case.
Why don't you tell us?
Math problems, it's the end of the show. We are letting you go till the next episode. Try to crack the code, keep solving the play. Loosen up, do a couple math problems a day.